You cannot write so many significant figure.
Uh-huh.
Accurate. This one is 3 significant figure. This one is 3 significant figure. This is 2 significant figure. So your answer should be follow 2 significant figure.
Why cannot 3?
Cannot 3. Because it's determined by the least accurate number of significant figure.
Oh, okay.
The idea is you cannot measure something that is more accurate than what you can get lah. What's the point
Yeah.
of wasting your time to measure more accurate when you can
This
when your instrument limit you to that percentage, that uncertainty? Errors will help you to understand why lah.
okay.
Right? Number of significant figure follow the least accurate value. Okay, what's the reading for this one?
Um 5 8 what's yeah. Oh boy. Yeah. 7.5.4.
Can or not? 7.64.
Oh, like that. Okay.
Here is 7.5 7, then it just passed 5 so 7.5, and this one is 14. 14 it should be rated right at 0.14 millimeter.
Oh, yeah. Okay.
Okay. Okay, the rest you can try yourself. Okay, making graph into a straight line. What is the answer for this one?
F against M will be inversely proportional, right?
Which one of the following plot will make into a straight line?
Okay. Straight line meaning from zero.
It will pass through zero, no? Pass through
Partial
origin.
zero.
Straight line passing through origin.
D.
B. Right?
I think I know why.
You can square that
Oh, yeah.
and then take all the constant to one side. Then it's 1 over f, no? F squared against 1 over m. Now about this one.
C. A.
Right? They are given you.
Uh, either B. No, either wait. It's either B or C.
It cannot be A or B because it cannot pass through that, cannot touch the line, cannot touch the y-axis or the x-axis. So it should be
Oh, yeah.
donkey.
Wait,
Okay,
what?
donkey.
Oh,
D.
yeah. Okay, I understand. Because directly proportional.
So you must be able to recognize parabola, rectangular. Which one is rectangular hyperbola? Which one is which? A is what? Which equation?
A is wait
You got three equations for you to choose to place in the right graph.
B or C?
Yep. A is what? You got A, B, C to choose.
I think it's C. A no.
Right? B,
Okay, yeah.
C is that? Right? This is more
Yeah.
like this one you use in A2 lah, when you study gravitation.
Oh, okay.
Okay,
Yeah.
okay. Let's go to errors and uncertainty. 1.3a. Random error. Estimate random error. Combination of errors. Right? That means when you multiply the quantity, divide the quantity, subtract or add the quantity, how do you do the, how do you combine the error? Then we go to systematic error, effect of errors on graph. This book, all the physics and chemistry constants are there lah, that you determine in your physics lab. You can find it accurately measure. Random error, measuring of length. Example is not 25, right? It's 20, not 25, not 26, it's between them. So I have to estimate as 25.5. That's why it's
Yeah.
error. Some will say 25.4, 25.3, 25.6. It's okay. We won't argue about that. Right? We have to estimate between that. So we call it error due to observer or need to estimate the last significant figure. Right? 25.5. Okay. Repeated reading to get the best estimate. Right? A student A, is from a worksheet there, page 39, number 32. The student measure G, and that is the value of G. Right? The mean value, you add all of them together, divide by 6, 6 reading, you get 9.82. The true value is 9.81. So random error, errors that cause reading to scatter equally about the true value. True value is 9.81. So some value are smaller, some value are larger. So memorize either the previous one, you have to estimate the last significant figure, or if it's a sample, readings scatter equally about the true value. Values above or below the true value and are not constant. Right? It's not constant. So memorize reading errors that cause reading to scatter equally about true value. Measurement of length. Example will be measurement of length, diameter of wire, room temperature. Why? Why do we have random error? Error due to observer, as you need to estimate the last significant figure. Can we reduce it or can we eliminate it or not? Can be reduced by taking more reading of the quantity and finding the mean if it's a sample, or by plotting a graph and drawing the line of best fit. Stop me if I'm going too fast.
Yeah.
So terminology, maximum possible error, uncertainty. Symbol, right? Either small letter or big letter, triangle there. Both are Greek alphabet for delta. Error is a deviation from the correct value. Right? We write as L plus minus delta L. Delta L is the uncertainty, L is the measurement. So example, 2.5 plus minus 0.1 cm. So it tells us that the actual value is between 2.4 and 2.6. 2.5, how do we get 2.4? 2.5 minus 0.1. 2.6 is 2.5 plus 0.1. Okay, individual or single measurement. Smallest gradation is between two lines now, right? Which is in this case is 0.1 cm. This is a piece of wood that we are going to measure. There's your ruler. Initial reading, Ri, 0. Right? Of course, when you read, there's uncertainty there, 0.05 cm. Final reading at this end there, 2.5. But there's still uncertainty. You cannot say it's exactly 2.5, it can be 2.4, it can be 2.6, slightly. But that's your best your estimate. So it's as an uncertainty of 0.05. So each measurement of length involves two readings, initial reading and final reading. Error in reading, half smallest graduation,
What's
0.05.
graduation?
Say again,
What is graduation?
yeah, graduation between two small lines there. There's the smallest graduation, one division, two line, called the smallest graduation, no? 0.1,
Uh,
0.1 cm,
oh, the smallest graduation, 0.1 ah.
0.1,
Oh,
the distance between the two line, 0.1 cm. Lah. So estimate is 0.05 cm. Lah. So in the exam, you are allowed to make
plus
that
minus.
amount of error in your reading of graph also. Lah.
Plus minus 0.05 ah.
Smallest graduation or smallest division divided by 2. That's the amount of error you are allowed to make. Lah. And that's the error we estimate, 0.05 cm for each reading. That's why we write the 0.05 for the first one, initial reading, and final reading 0.05.
Okay, I get it.
Okay, in 10 minutes time we will talk. So I would think I want to have another session about 10 to 15 minutes, 10 to 20 minutes, I'm not sure. But we try to cover as much as we can.
Okay. Sure, maybe we
Yeah.
should have one extra class.
You want
Top
one
up one
extra
extra.
class, right?
Within either this weekend or next weekday.
You think about it, and then you tell me when you want to add extra class.
Ah,
Okay, so the length is the final reading minus initial reading is 2.5 plus 0.1. Okay, you add the two error. No? That's why you get your 0.1. No? We add the absolute error 0.05 plus 0.05 is 0.1 cm. Okay, for single measurement, smallest graduation, example meter rule 0.1 cm. So we write as 2.5 plus minus 0.1 cm. Right? 0.1 is called uncertainty or errors, and it's always written to one significant figure. Number of significant figure for L follows the error, follow the uncertainty. That means one decimal place only. This is one decimal place. This one also one decimal place. So the length is between 2.4 and 2.6 cm. Not one value, but that's why it's called uncertainty. The, the length is actually between 2.4 to 2.6 cm.
okay.
right? So the uncertainty in measurement is always equal to smallest graduation, right?
Or means
Reading
like what the smallest unit the
graduation, no?
apparatus can.
If it's one reading, then you divide by 2, no? But if it's measurement, then you just take the smallest graduation, no?
The smallest reading the apparatus can read,
Ah,
meaning
the smallest division, no?
what in what scenario divide by 2 again?
Divide by 2 is if it's initial reading and final reading. Okay?
Okay.
Right? Error in measurement is smallest graduation. So in this case, right, no point is reading to 2.55 lah. You read 2.6 plus minus 0.1 millimeter. Right? Can we write it this way? Cannot. Right? This is not the right way to write the answer. Answer is 1 decimal point for uncertainty, 1 decimal point for the answer. Okay?
Yep.
Okay, let's
Wait, cannot do.
cannot.
Okay,
Uncertainty
so
is
only
already
one.
uncertain already. Right? This is already uncertain already. What for you want to write 2.21? Right? It's
Yeah.
1 decimal place. One significant figure, not one decimal, one significant figure. So 1 decimal place here. This one also 1 decimal place. Okay?
Okay.
Absolute error delta L means positive value only. Proportional error or fractional error is delta L over L. Percentage error, percentage delta L, right? That's my short form. It's delta L over L times 100%. That means proportional error times 100%. Rules for combining error, adding or subtracting. Quantities, sometimes we call the quantities measurement or variable, right? A plus minus delta A, yeah, uncertainty of delta A. B plus minus delta B. Adding or subtracting, example, A plus B equals to S. Difference, A minus B equals D. So delta S or delta D, we add the absolute error. That means we add delta A plus delta B. We never subtract. Memorize, right? Memorize.
Okay.
Multiplying or dividing, product, quotient. So delta P over P or delta Q over Q, we use fractional error. So it's delta A plus delta B plus B. Right? Working with percentage, we just times 100% throughout. So percentage error in P or percentage error in Q equals to percentage error in A plus percentage error in B.
Wait, teacher.
Yep.
Uh, delta delta A over delta A over A plus delta B over B. Like, what's that for?
That's called fractional
Is
error
uncertainty
or
or
proportional error.
huh?
You must know the what is called. Yeah.
It's not called uncertainty.
Say again.
Not called uncertainty, is it?
Uncertainty is delta
Oh,
L.
okay.
Okay, now
Oh yeah, yeah.
you must know the meaning of each term. Proportional error
Oh
or
yeah, yeah.
fractional error. Percentage error is times 100%. Any
Percentage in error. Okay.
problem? You will lose it.
No.
I want to take extra time to do some work. Okay, so you can either add
Ah,
proportional error or add percentage error or multiply or divide. Right? Adding or subtraction, you just add the absolute error. Subtraction, the same thing. Right? You never subtract because you subtract, you can get 0 or you can get negative. but there's no such thing as negative error. The error will always add up. You will get worse.
Oh,
You will never get better. Right? So you add. Right? And like
oh,
example,
teacher, so if it, oh, okay.
okay or not?
Yeah, okay.
Is multiplying, same. A will have proportional error, delta A over A, L will delta L over L, delta B over V. You just add them up. Or you use percentage error, same thing. Right? Just stress to you. Power, same thing. You multiply, you just add the fractional error or proportional error. If it's L squared, it's delta L over L plus delta B over V, right, which is 2 delta L. That's where the square comes in. Though. Square becomes multiplied by 2. Though. Okay,
Okay. Yeah, okay. So wait, when it's multiplying, we use the proportional error.
yep.
How about division, dividing?
Dividing the same. That's why we give you the rule just now.
Oh, so multiply or divide all is the same
Multiply
one
or
lah. We
divide.
won't.
There, divide, multiply.
Oh, okay, okay. Yeah, because I didn't understand the writing. Yeah.
Okay,
Okay.
so during the break, you just have a look through and try some of the question.
Which page?
Then we will spend another 10 to 20 minutes. So we get like 1 minute,
Page, ah?
less than 1 minute left. So we will be stopped anytime. So try the question. I've sent you already. Don't ask me to. You are wasting a lot of time now by asking the same question. I send you all the thing already.
Oh, sorry, sorry, sorry.
Okay, delta y over y is delta a over a. Let's multiply them. Then is 3 delta a over a. Lor. Okay, so you the power to power n, you just times n, that's all. Proportional error times delta a over a times n times, or percentage error in a times